Let us now learn oxidative decarboxylation of pyruvate, which is the second step in aerobic respiration. And this operates after glycolysis, provided there is presence of oxygen, right? So we have learned in our earlier lessons that glucose gets converted to pyruvate. So in cell cytoplasm, per glucose molecule gets converted to 2 molecules of pyruvic acid, generating net 2 ATP and 2 molecules of NADH. Now, let us consider this as aerobic respiration. So in presence of oxygen, imagine there is oxygen availability in your cells. So in presence of oxygen, pyruvate will enter the mitochondria, which is the powerhouse of the cell, right? We love mitochondria because it helps us in sustaining our cellular activity by generating abundance of ATP. Now you see, pyruvate enters the mitochondria. Which component of the mitochondria? That is matrix, right? It enters the mitochondrial matrix, and as it enters, it encounters with the PDC. And what does PDC stand for? It is pyruvate dehydrogenase complex. It is an enzyme available in the matrix of the mitochondria. So this enzyme is capable of removing carbon. We call it decarboxylation. It is also capable of removing hydrogen from the pyruvate. And if the hydrogen gets removed, we call it dehydrogenation. Now imagine the pyruvate, from the pyruvate, carbon is removed. As the carbon is removed, it results in the formation of carbon dioxide, which is released as waste, right? It also removes hydrogen from the pyruvate. And as the hydrogen gets removed, it gets accepted by NAD+. You see? And as hydrogen gets accepted by NAD+, it results in the formation of, yes, expected NADH, which is our favorite energy carrier molecule. Now you see, pyruvate is no more pyruvate, right? Pyruvate should have it should have 3 carbon atoms. Now there's only 2 carbon atoms, right? So we call it as acetyl group. Now, with the formation of acetyl group from the pyruvate, coenzyme A will combine with the fragmented 2 carbon in acetyl group, and it will transform into acetyl coenzyme A. So that's how pyruvate gets converted to acetyl CoA in the mitochondrial matrix in presence of oxygen. Now where do you think this acetyl CoA will go? Yes, it is going to the Krebs cycle. Our favorite cycle because it helps in generation of abundance of ATP in later stages of cellular respiration. And remember, Krebs cycle cannot operate without acetyl CoA. Just like we can't eat food without salt, right? So it is necessary. Acetyl CoA is a necessary molecule for Krebs cycle to operate. So what is the purpose of link reaction? From the title itself, it links glycolysis to Krebs cycle. Now why it is so necessary to link? Because without acetyl CoA, Krebs cycle can never operate. And if Krebs cycle do not operate, ATP production gets severely impaired. And remember, my students, without ATP, no cells can survive. So therefore, be grateful that we have PDC in our mitochondria. So to sum up, pyruvate enters the mitochondria and undergo decarboxylation, which results in the removal of carbon dioxide, and undergo dehydrogenation, which results in the formation of NADH, and this results in the formation of acetyl group, which gets further added on by the coenzyme A and results in the formation of acetyl CoA, which is the necessary entrant substrate for Krebs cycle. Since there are 2 molecules of pyruvate generated per glucose, you should be aware that there will be generation of 2 acetyl coenzyme A, 2 NADH, and release of 2 carbon dioxide. And therefore, Krebs cycle has to turn twice. per glucose molecule oxidation. Now I want you to try this question. I got it from internet. You have to label A, B, C, D, 1, 2, and 3. Go and give a try. If you're not able to solve it, and if you come across any doubt, don't hesitate to leave a comment. See you next time.